What is the theoretical percent composition, and that'll be by mass, of each of the elements in dinitrogen disulfide? Again, here we're going to assume that we have 1 mole of our compound, and from that, using the molar mass, we're going to be able to determine how many grams are in 1 mole. Our percent composition is, of course, percent is part divided by the whole. So in a problem like this, each part is going to be each element in the compound, and the whole is going to be the entire compound itself. But specifically, we want the grams of each element divided by the grams of the whole element, the whole compound, I'm sorry, times 100. So we're going to have to do this calculation for as many elements in the compound. In this case, we have 2 elements, nitrogen and sulfur, so we're going to have to do 2 calculations. So let's write our elements, nitrogen and sulfur. And since the numerator is grams of each element, the question is, how many grams do I have of nitrogen in 1 mole of this compound? Well, looking at the formula, we see that we have 2 moles of nitrogen in 1 mole of the compound. So again, as in problem number 1, we're going to start in a similar manner. We're going to write the 2 moles of our nitrogen. And now to get grams, we're going to use the molar mass. So let's go to the periodic table and find the molar mass of nitrogen. We saw nitrogen earlier, element number 7, molar mass of 14.01. So we bring that number up here, 14.01 grams per mole. Moles cancel. I'm left with 28.02 grams of nitrogen in 1 mole of the compound. And note the unit here is exactly what we want in the numerator for our calculation. We're now going to do the same calculation for sulfur. We also have 2 atoms of sulfur in 1 molecule, or 2 moles of sulfur in 1 mole of the compound. So I'm going to write 2 moles as well. And now I need the molar mass of sulfur. Going back to the periodic table, we saw sulfur already as well, 32.07 grams per mole. So let's write that, 32.07 grams per mole. Multiplying that, we get 64.14 grams of sulfur in this compound. And again, just like with nitrogen, our numerator here in our mass percent composition is also grams, so that's going to be good to go. Now we need to add this up to get the denominator value, the grams in 1 mole of the compound. So adding this up together, we're going to get a value of 92.16 grams in 1 mole of N2S2, and this goes into the denominator. So now we can calculate our mass percent of each element. So percent nitrogen is going to be simply equal to the mass of nitrogen in 1 mole of the compound, which is what we just calculated right here. So that goes upstairs, 28.02 grams. Downstairs, let's use blue to highlight. That's going to be in our denominator, the mass in 1 mole of the compound. So we have 92.16 grams. We want percent, we're going to multiply by 100. Grams cancel. And now when we do the math on that, we get 30.40%. And we have 4 significant figures in that calculation. And now we repeat the calculation for sulfur. Our percent sulfur is going to be equal to, now I'm going to get the mass of sulfur in 1 mole of the compound. We calculated that a few minutes ago at 64.14 grams. So that goes in the numerator, 64.14 grams, divided by, again, the blue shaded number here, the mass in 1 mole of the compound, 92.16 grams. Grams cancel, I'm going to multiply by 100 to get percent. And now doing the math on that, we get a value of 69.60%. Again, we have 4 significant figures. Now, here's an important thing. If we add these two percentages together, we must get 100% because the whole is equal to the sum of the parts. So we do add them, we get 100%, so we can be pretty sure that our calculations here are correct.